This video lecture is meant to continue our discussion on percent yield, and this time we are going to figure out percent yield from actual lab data. So what I have done is I've taken the data from the experiment that you did, mole ratios, which was the reaction of silver nitrate and copper wire, and it was a single replacement reaction where the copper wire dissolved into the blue copper nitrate, and the silver nitrate was separated and the silver metal precipitated out. And so from that reaction, we're going to figure out the percent yield of silver. So remember, percent yield is the actual yield divided by the theoretical yield, and then we're going to multiply that by 100. So the actual yield is what you did, how much silver was actually produced in the experiment. The theoretical yield is how much could have been made using the stoichiometry. So we have to kind of approach this from two separate problems before we get to the percent yield equation. We have to figure out theoretically how much silver should have been produced. That will go here. And then from our data table, we have to figure out how much silver actually was produced. And then from there, it's simple to figure out the percent yield. So the first question here guides us in this process and how to do this. The first thing we're going to is to figure out the theoretical yield of silver using stoichiometry. So in order to figure out how much silver we should have made, we are first going to figure out, we have to have a number to start with. And so what we're going to do is we're going to find the mass of the silver nitrate that was used up in the experiment. Now in the lab that we did, we determined the mass of the silver nitrate directly. We did not weigh the beaker that we measured the silver nitrate in to begin with. So this number right here, 1.46 grams of silver nitrate. Now, some of the data that you're going to see in the problems coming up, the silver nitrate was weighed in an empty beaker, so you may have to, in some of these problems, have to subtract out the weighing dish or the beaker, the vessel that the chemical was weighed in to begin with. But for this problem, it's pretty simple. We know we're starting with 1.46 grams of silver nitrate. So this is the number we're going to start with for part B. We're going to calculate the theoretical yield of silver. We're going to use our stoichiometry gram-gram skills and use the balanced equation below. So we're going to start with 1.46 grams of AgNO3. So we know we're starting with this mass, and we are trying to find the grams of the silver nitrate. Now the equation's already balanced for us, so this is a good thing. The first thing that we will do is convert grams of silver nitrate to moles of silver nitrate. And what you'll see here, this is a molar mass conversion. So if you add up a silver and a nitrogen and 3 oxygens to the nearest tenth, you will get 169.9 grams. Right? So that first fraction converts grams to moles for silver nitrate. The next fraction, we are going to convert moles of silver nitrate into moles of silver. And of course, this comes from the balanced equation. It's a 2-to-2 ratio, which makes our math very simple for that step. And one more step, because we're trying to find not moles of silver, we're trying to find grams of silver. This last fraction will take moles of silver and it will convert it to grams of silver. 1 mole of silver weighs 107.9 grams. So if we cancel out, we've got moles of silver canceling. We have moles of silver nitrate canceling, and we have grams of silver nitrate canceling. And so your math is 1.46 times 107.9. Divide that by 169.9, and you will get 0.927 grams. Okay, so that is our theoretical yield of silver. That's how much silver we should have made, assuming we used all 1.46 grams of silver nitrate, we should have gotten 0.927 grams of silver produced. Notice that I kept 3 significant figures in our answer because we had 3 significant figures in the 1.46 grams up above. All right, so now we have our theoretical yield of silver. That's the denominator for our percent yield problem. Okay, so this right here, this is going to go into theoretical yield for our percent yield equation. Now we have to figure out the actual yield, and so this is going to come from the data table, how much silver was actually measured in the beaker in this lab experiment. All right, so for this, you will find your piece of data that represents the beaker plus the silver, and you will subtract out the mass of the empty beaker, and that should give you your number. So if we look up above in our data, and I'm going to scroll up very quickly here, the mass of the beaker plus the silver metal is 113.71. The mass of the empty beaker, 112.75. When we plug that into our calculator, we get 0.96 grams of silver. So this number right here represents our actual yield. So here we see that our actual yield is a little bit heavier than what we were supposed to get. And since you can't actually get more silver than you were supposed to get, this tells me that this sample was probably contaminated. It probably was not cleaned up of all the copper nitrate. But that's okay, it's pretty close to the silver that was expected, so this lab group did a pretty good job. All right, so now let's take these two numbers and figure out the percent yield of silver in this lab experiment. We will take our actual yield of 0.96 grams, and we will divide that by our theoretical yield of 0.927 grams, and we will multiply that by 100. And so when we put this into our calculator, we get a number that is greater than 100%. If we round this to the nearest whole number, you get 104%. And I do recognize that that's not two significant figures, but for this purpose, we'll just leave it at that. So we have a 104%, which is not really possible, so therefore we have a contamination. All right, let's take a look at the next problem using lab data. So here we have the mass of the empty beaker at 93.80 grams. We have a beaker with silver nitrate, and we have a beaker with silver crystals. So this problem is starts out a little bit differently, but only in the fact that we'll have to figure out the mass of the silver nitrate. You'll have to first subtract out the empty beaker. So here, you have to take the beaker and the silver nitrate and subtract out the empty beaker. Okay. So I'm going to go ahead and you should pause the video right now and come back and see what, if your answer is verified with mine. So you should have 95.90 minus 93.80, and so the difference in grams there is 2.10 grams. So that right there is the mass of the silver nitrate. Now this number is not going to go into your percent yield equation. This is just the starting number that you're going to use for your stoichiometry in part B. Right? Remember our percent yield, we're trying to find percent yield of silver, the silver metal. Okay, not silver nitrate. All right, part B, set up your stoichiometry problem. You know that you are starting with you're starting with 2.10 grams of silver nitrate, and you are trying to find the theoretical yield of silver, and so that's what's accomplished by this stoichiometry problem. So pause the video now, try the problem on your own, and come back to check your work. So if you've set up your problem correctly and rounded your answer appropriately, you should find that the theoretical yield of silver is 1.33 grams. Alright, so that's the bottom part of our percent yield problem. To find the actual yield of silver, this is from the data table. So we go to the data table to find the actual yield of silver. This is a problem where you have to subtract the beaker with the silver minus subtracting out the mass of the empty beaker to find the actual yield of silver. So pause the video now to see if you can do this on your own, and when you start the video again, the answer will be here for you to check. Alright, so you should have 1.15 grams of silver that was actually produced. Now, for the last step of this problem, to find the percent yield of silver, you will use the two answers you just found in part B and C to figure out percent yield. So pause the video now, try your work, come back and check your answers. Alright, you should find that the percent yield of silver from this problem works out to 86.5%. Alright, there's one more problem for you to try. It's a slightly different experiment. This is the last page of your percent yield handout. So you have sodium carbonate reacting with sulfuric acid, producing sodium sulfate, water, and carbon dioxide, and is shown in the balanced equation below. The data was collected and recorded in the data shown below. So what you have is the mass of the empty beaker right here. You have the beaker and the sodium carbonate here. Keep in mind sodium carbonate is Na2CO3. And the mass of the beaker and the sodium sulfate is 43.7 grams. Sodium sulfate is Na2SO4. So make sure you are looking at the correct compounds before you do the work. So go ahead, pause the videos, try working through the problems. So pause the video, work through your problems, and come back here for an answer check. So here you can see, part A, you should have found that 3.2 grams of sodium carbonate was used up. You're going to use that 3.2 grams of sodium carbonate in a three-step stoichiometric problem in part B. And so 3.2 grams of sodium carbonate works out to a theoretical yield of 4.2 grams of sodium sulfate. Scrolling down, finding the amount of sodium sulfate actually produced is 4.1 grams. So 4.1 divided by 4.3 times 100 gives you a 95% yield of sodium sulfate. Alright, that concludes this video lecture on percent yield. We'll see you in the classroom.